finally got a chance to talk to you. I know things have been hectic and busy for everybody, so this is we greatly appreciate your time. We really do. Valentina, thank you again. Valentina Zharkova, we are excited to speak with you today. And I guess basically I wanted to ask real quick before we get started a little bit about yourself and your background. What is your primary subject of research?
Primary subject of research?
Yes.
Theoretical astrophysics.
Okay.
I do plasma physics in solar flares, in solar prominences. I do particle acceleration and precipitation and so on. So this is my primary research. I'm plasma physicist investigating solar plasma in particular.
Okay.
So this is why we came to the involving the theoretician, because I wanted to understand as a physicist what is causing these waves.
Right.
I can explain very nicely flares and what is produced by them, different emission from the corona to the photosphere and sunquakes, but this was absolutely puzzling. So we needed specialists from different fields who can explain us and bring us very nice theory of dynamo machine on the sun.
What got you started in this particular kind of research that you do?
I am an applied mathematician, does a lot of modeling, and my main topic was active region, particle acceleration, which I was doing most of the, and radiative transfer. But in 2002, we got European project within Framework 5 to do automated pattern recognition of solar features. And we done a large catalog for about maybe 10, 14 years. And we got the data set, which we created ourselves, of sunspots and active region and filaments, which made me motivated to use these data sets.
Yeah.
If we create them automatically using nice, codes and everything and all the methods, we wanted to do some first flavor of utilizing these statistics. So we started doing statistical analysis in 2004-05 and slowly progressed from sunspots. We discovered that sunspots are not very good proxies describing this activity because detection of them introduces a lot of errors. But when you look at the bigger features, they produce less errors. So we thought, maybe there is something which can give us better proxy of solar activity. And we thought, all right, there is a magnetic field which measured on the whole solar disk and gives you 1024 by 1024 pixels instead of like 50 pixels on the whole disk. So the accuracy is much better. This is why we decided to look at the magnetic field, and given the experience and statistic we gained on the sunspots, eventually we started doing artificial intelligence methods with this data, because we were doing with catalogs which we developed. So this is how, being pure theoretical physicist, I moved slightly towards the statistical physics, and this is how we arrived analyzing the magnetic field with the principal computers in 2000. So this is how it happened.
You work at Northumbria University, correct? And
yes.
how long have you been with them?
4 years.
4 years?
2013, yeah. And before I was working for 13 years at Bradford University. So my research in statistics started from Bradford University, and this is why I still have a collaborator from there. We basically started together, and then we move on.
The next thing I was going to go into was your work wasn't received very well with some people in what we would say the global warming community. What was that like at first? I mean, I'm sure that you weren't thrilled about the data set that you were coming across. So this wasn't like you were trying to go against the grain. You were just doing your job.
Yes, my work actually is very well received in other part of the research, because I published about 3 papers in Nature. I was the one who discovered sunquakes, and if you trail back 1998 May, you discover that it was coverage in all media about this discovery. Then it was this discovery of upcoming Mount the Minimum, and recently in this June we published another paper in Nature explaining, returning back to solar flares and explaining some particular feature in flares. So
Okay.
I'm doing this in between, and what I've done with the statistical analysis and prediction is like extracurriculum activity. Simply, we discovered interesting effect, and we didn't want to leave it because it was so overwhelming. We
Right.
didn't realize that nobody could see it, and it simply came up to us as a gift, I would say, because nobody expected what we got. We done this principal component analysis, which I, curiously enough, teach my students when I explain them how to solve differential equations. I describe them eigenvalues, eigenvectors, we calculate with them everything. So, and at the same time, when we did our paper in scientific report, I was teaching my students also the waves. And this was first time I was teaching the waves to large audience of students, about 70 or 80. And this gave me some links for what we do. Maybe I can find answers in this basic theory of waves. And this is why when we got the results, I was surprised that nobody looked. Everything was developed in the wave theory.
Yeah.
People simply look at it and didn't notice it. This is what happened. Sometimes we're overlooked, interested in their own theory and not looking at the basics. This is probably what happened.
Valentina, we've been following your work for some time. I have so much respect for you and the research you've done. I'd like to thank you for coming on to the Grand Solar Minimum channel to discuss this research. Your new model promises a 97% accuracy. Your research is exactly what we need to get the people, our viewers, prepared for the future. First off, when you talk about the decrease in the power of the sun and the magnetic fields going 180 degrees out of phase, you state the sun's output power will decrease. Now, are you talking about the decrease as in TSI level or just the magnetic field on the sun that's creating the sunspots? Can you go into that a little bit more for our viewers?
I'm speaking only about the magnetic field of the sun. We did not calculate any TSI. And even in the previous Mount Minimum, the TSI was reduced by 3% only. So obviously, the total solar radiance will not be reduced dramatically. And it was not reduced in the Mount Minimum. But something happens with the magnetic field. Magnetic field comes like into hibernation period, but it doesn't mean the sun stopped working, producing dynamo waves. What we gave very good explanation. The sun is still working very hard like our heart in the human body, but simply what it produces 2 waves which interfere with each other, and they cause this solar activity over the 400 years. And once per 400 years, these waves suddenly come up into the opposite antiphase. And the standard interference theory of waves show when the waves are in interface, they cancel each other. This is how people work out the noise reduction techniques, right? They put wave opposite in opposite phase, and your noise is reduced and so on. So this is standard thing. And similar happens on the sun.
Yeah. Do you think that while those 2 hemispherical waves are going 180 out of phase, that it creates additional instability around the equatorial region, which may lead to more or larger CME type events? prior to the full cancellation or the two waves coming 180 degrees out of phase?
I cannot speculate about it, but normally when the magnetic field of the sun is reduced, we see much less sunspots or no sunspot whatsoever. And we predicted in our recent paper that the number of sunspots will reduce very dramatically by 70% compared to the current cycle, which means if we don't see sunspots are places where these loops are embedded into the photosphere. It means you don't have these loops. They do not show up on the surface. So there will not be active region from which these coronal mass ejections can appear. So theoretically, yes, magnetic field reduced and they can appear. But the problem is, if magnetic field is reduced, it's reduced all over the solar interior, so there are much less flux tube appear on the surface. So there's no sunspots. If no sunspot, there's no activity whatsoever.
The solar cycle's coming up, with there's predictions of 0 sunspots at some point at solar cycle 26, 27. And this is just an obvious question here, but, everybody, there are people that just believe we're going into a minimum. What we see that we are going into a grand solar minimum, that this is not just a solar minimum, but the grand solar minimum.
Yes, it will be grand solar minimum because we coming now to the minimum between 24th and 25th cycle.
Right.
You see there's no sunspots, but still there were enough active region to produce enough heat waves on the Earth and enough radiance. But the more we come into the cycle 26, will be less and less sunspots. So maybe in 5 years' time or 5-10 years' time, we can meet if we both wealthy and good and discuss that, in July we need to go in court because it's very cold outside. So this what probably will happen during this global minimum, not from normal minimum. Of course, during the normal minimum, the temperature slightly decrease on the Earth. It's well known. But this, during the global, it will be much more decreased. And I look at the observations by Lean et al., who restored the temperatures during the mountain minimum, which was 400 years ago. Temperature was decreased about 1.5 Celsius in the northern hemisphere. Right. And no one knows what was in the southern hemisphere because we didn't have researchers there. And even this small decrease caused very long winters and frozen rivers and everything. So maybe we will not have that dramatic decrease, but we still have decrease global.
Valentina, so when you look at the magnetic fields, many of our viewers are well versed in the terminology of your research. They understand gales and things of that nature. Could you give a technical description of what's transpiring as to where were we as far as our magnetic field on the sun in gales? Where do you think they will drop to? At what point do you think we will stop seeing sunspots? And how close to that are we?
I need to look. You can look at the plots in the Nature paper, Nature Scientific Reports paper. But magnetic field drops by nearly 10 times compared to cycle 21. Compared to cycle 23, it reduces by factor 4. So it is magnetic field which expands into the solar system and which basically protects the solar system from harming cosmic rays from galaxies and external. So probably this will be the main effect on the solar system, that we got more external visitors, so cosmic rays coming from galaxies and supernovas and somewhere else. But the good news is that in 30 years, sun will return back to normal and restores its power and start protecting us. And given that we calculated this magnetic field 3,000 years back and discovered it keep repeating every millennium, and people manage to survive the global warming during the Roman period. They had very strong heating, and they had Homer cooling period. We managed to calculate it. So obviously the planet and humankind as such, they survived all these periods. Simply we in the short lifespan, a few 50 years, when the science became very powerful and people started publishing everything is available on the internet, suddenly it came to us as a surprise. But this surprise was happening in the few millennia, if not even longer, on the Earth. And it is not a big surprise for the Earth.
How long have you been working on your model, and how accurate is it?
The model actually been developed in collaboration with Russian scientist Elena Popova, because what we done, we published paper on principal component analysis in 2012, which didn't include model at all. What we discovered, these two ways, we derived them from observations. And then in 2014, we derived analytical description of these waves in formulas. We managed to derive them. And when we got those two waves, the analytical description was so amazing that we wanted to understand where the wave comes from. So we invited Elena Popova, who was finishing her PhD in Moscow University, just to look if we can find any dynamo models which explain these particular two waves which we discovered. And very fresh from her PhD, she found that indeed there is a Parker model. Parker is the guy who introduced the dynamo to the community, and he applied this model to two layers. He didn't know there are two layers, but he felt probably intuitively that it should be two layers. And Elena modified this model by adding these two layers with different meridional circulation, which allows her to obtain the waves with different frequencies or different periods, which form this beating effect and produce the global minima. So thanks to her, she used not very complicated model. Basically, of course, it is a model including the induction equation and including equation for transforming poloidal solar field into toroidal through vector potential. So they're all dynamo equations, but they are applied to two different layers. And we used low model approximation. So we didn't use clusters. We used simple computers. Low model approximation because our observations show that we can reproduce these waves with about 5 or 6 cosine functions. So it's very close to the approximation of low modes for reproducing Parker models. So we use this the same approximation explaining our, and this gave us a success. We suddenly realized that these principal components which we found, or two main waves, are indeed produced by dipole magnetic sources, exactly as Parker suggested, because now his equations allow to reproduce very nicely these principal component curves, which before they couldn't reproduce because they were polluted with other components which add into the magnetic field. So this is what happened. And this was a contribution of Elena, because she managed to bring the expertise in solar dynamo and gave us explanation how these waves could be generated and which parameter could affect how they can come to the beating effect which we observed.
Excellent. Valentina, out of the many different theories out there in regards to the universe, can you tell me what theory you and your team follow?
I didn't hear this theory. We followed the dynamo theory developed by Eugene Parker from Chicago, very famous scientist, to follow. We followed the classic theories explaining the solar activity dynamo. The only thing we changed, we introduced the two waves. The one wave generated the bottom of the sun near convective zone, and another waves are generated is generated by the solar interior itself, which acts as a resonator, and the wave generated by solar dynamo travels through this resonator, interfere with this wave, and produces the visible solar activity, which we see as a sunspot.
In your paper, you predict the upcoming modern grand minimum, or eddy minimum, in 2020 through 2055, which will have the solar activity slightly higher and its duration twice as short than the Maunder minimum of the 17th century. Can you give examples as to how much higher that will be compared to in other minimums we've encountered?
In 400 years ago, Maunder minimum, the magnetic field dropped much lower, so the Maunder minimum period lasted for 60 years. So obviously, magnetic field, I don't remember by heart this our diagram, but it was much lower than the current one. We recently simulated the butterfly diagrams for the current global minimum compared to the Maunder minimum, and we found that we will have more sunspots in the current grand minimum compared to Maunder. So it will not be that cold like it was 400 years ago. We will have a little bit more sunspots, but to look qualitatively, quantitatively, probably you better look at the paper. I wish I can send you the link, and you will see how much it will be decreased. But we anticipate it will be decreased less than it was 400 years ago, because the current grand minimum will last only 3 solar cycles compared to 6 solar cycles in Maunder minimum. And the magnitude of magnetic field is reduced not as dramatically as 400 years ago.
So you, in dealing with particle physics, are you following the work from Jasper Kirkby from the Cloud Project at CERN about the interaction of cosmic and galactic rays in our atmosphere, increasing cloud nucleation?
I follow the work remotely from CERN because I'm not particle physicist, but I'm familiar with it. Mostly I'm interested and been recently attending IU symposium as well on the effect of the cosmic rays on the geomagnetic environment and in the past years. And so I follow this one. Yeah, I feel it will be important in the next few decades. It will be key player, which is not possibly properly included into the current model predicting the temperature, because none of them predicting that the temperature will drop. They say and the temperature will increase. Well, we will see in 5-10 years who is right, and it is not far away, so you definitely will be able to judge on your own who is right. And I stand what I said. I'm completely confident what we done is correct.
Yeah, and you said it right there. 5 to 10 years, we're going to see who's right. I think that is accurate. This is not something that we're going to be able to witness overnight. It's not a fly-by-night thing, but we are starting to see the signs that we are heading into this grand solar minimum. We feel like it's also accelerated, not just creeping up, but it's actually accelerated. So, I agree with that statement there.
I got invitation for interview Al Jazeera before they had this trouble with the other Arab country. But what they said, they didn't have snow for the past observation 150 years, never had snow. And they had snow in April, April. And it was cold in the desert, which not a positive temperature. And they said definitely whatever they say, they're respectful of what we suggest much more than any other things, because they see with their own coat, they need to wear a coat, they need to put heating on in the desert, for God's sake.
Last year, we covered a story where they were putting long johns on the elephants out there. So, I mean...
Yeah, this is happening.
It's crazy.
And they're in denial. They want to close their eyes. They said it's coming global warming. You have 5-day temperature high. I don't know how it is in America, but we had 5 hot days temperature. Says, it is global warming. But the whole July, we cannot go without jackets. And it is cold. It is 15 degrees in July. And we say, we should be lucky we go in the jackets, not in the overcoats. because in the few years we will be going overcoats, and this is what's happening.
We are actually, that's Mari and myself. We live in Buffalo, New York. Most of July, we have worn hoodies or jackets in the evenings, and that's just not, your skin is cold to the touch. The thermometer says 78, but your skin is cold to the touch once you feel that wind blowing. So, absolutely, we're already seeing that. And yeah, next July, who knows how much worse that's going to be.
This is unfortunate. And what is, people can take clothes and do okay, but what will happen the same happened, in Europe. I don't know if they reported in America. We got shortage of courgettes and broccoli and other nice vegetables because in Portugal and Spain, they had very strong snow and frost in April, and they couldn't produce this vegetable. They're frozen out.
Wow.
So we had shortage in the UK. Okay, they close ice and say, right, this happened once, it will never happen in Spain and Portugal again. But we had shortage of this. And this shortage of food will be repeating because the warm period will be not enough to produce some harvest. And the government should be thinking how to feed the population instead of thinking how to protect them from hypothetical global warming, which probably will be maybe on the equation in 30 years' time when the cooling period goes away.
We are 100% agreeable with that statement there.
Yes, indeed. We're featuring a place on our website for people to gather and discuss adapting to the changes we'll be facing in the near future. As we go into the decreased magnetic field of the sun, do you see an increase in the size of coronal holes? Do you think they'll become more prevalent as we get weaker going into this cycle?
It can be. No one knows. The whole sun is a set of those big flux tube and whatever. So what it means that if you don't have intermediate flux tubes in the on the solar surface, it means that the most of the solar energy will be probably put into these large coronal holes on the north and in the south, which will be probably keeping the sun like in order into the single flux tube or something. This my intuitive perception. Of course, I did not do the simulation, but now people do observe some increase of size of the coronal holes near poles and so on. So probably this will happen. And again, we will witness this. We live very historical time when we can witness this grand minimum right away in the sun. They send in a lot of instruments to view the sun. Of course, they wanted to see solar flares and the active region. I said, guys, probably you should stick to your investigation of solar magnetic field because not much of others you would see there.
Right.
This was
during this minimum, absolutely. Yeah.
Yes.
Now, I've seen that NASA's Parker Solar Probe mission is due to happen in 2018. They're saying that this will revolutionize our understanding of the sun. This probe will provide us some new data on solar activity. It will study the corona. Have you heard about that mission?
Interesting development, and the new instrument called Solar Orbiter will be flying exactly above the North Pole, trying to catch pictures and make observations. So we will be straight in the front row watching the action.
Wow.
This will be luckily visible. So, and we will have answer. They hope they launch this instrument within the next 5 years. So obviously you will have your answer probably right away in the publication by the instrument developers.
Let's hope.
Yeah. Also.
Well, Valentina Zharkova, thank you so much for joining us at the Grand Solar Minimum channel. It has been an absolute pleasure to talk to you. Again, we thank you for coming on, spending a little time, and answering a few questions for us.
Okay, thank you very much, and good luck. Hopefully, we will get through this.
That's right. That's the hope. We're here. Yeah, we're here to thrive. That's what we're here to try to teach: is how to thrive.
If Roman managed to to get through. We should manage with all power and technologies. Humankind should get through, become wiser, hopefully, during this passing by. But we should get through. Thanks very much.
All right.
Goodbye.
Take care.
Bye-bye. Nice, codes and everything and all the methods. We wanted to do some first flavor of utilizing these statistics. So we started doing statistical analysis in 2004-05 and slowly progressed from sunspots. We discovered that sunspots are not very good proxies describing this activity because detection of them introduces a lot of errors. But when you look at the bigger features, they produce less errors. Or we thought, oh, maybe there is something which can give us better proxy of solar activity. And we thought, all right, there is a magnetic field which measured on the whole solar disk and gives you 1024 by 1024 pixels instead of like 50 pixels on the whole disk. So the accuracy is much better. This is why we decided to look at the magnetic field, and given the experience in it's very nice theory of dynamo machine on the sun.
What got you started in this particular kind of research that you do?
I am an applied mathematician, does a lot of modeling, and my main topic was active region, particle acceleration, which I was doing most of the and radiative transfer. But in 2002, we got European project within Framework 5 to do automated pattern recognition of solar features. And we done a large catalog for about maybe 10, 14 years. And we got the data set, which we created ourselves, of sunspots and active region and filaments, which made me motivated to use these data sets.
Yeah.
If we create them automatically using
We're thrilled we finally got a chance to talk to you. I know things have been hectic and busy for everybody, so this is we greatly appreciate your time. We really do. Valentina, thank you again. Valentina Zharkova. We are excited to speak with you today. And I guess basically I wanted to ask real quick before we get started a little bit about yourself and your background. What is your primary subject of
statistic we gained on the sunspots? Eventually we started doing artificial intelligence methods with this data because we were doing with catalogs which we developed. So this is how, being pure theoretical physicist, I moved slightly towards the statistical physics, and this is how we arrived analyzing the magnetic field with the principal computers in 2000. So this is how it happened.
You work at Northumbria University, correct? And
Yes.
how long have you been with them?
4 years.
4
Since
years?
2003, yeah. And before I was working for 13 years at Bradford University, so my research in statistics started from Bradford University. And
Research.
primary subject of research.
Yes.
Theoretical astrophysics.
Okay.
I do plasma physics in solar flares, in solar prominences. I do particle acceleration and precipitation and so on. So this is my primary research. I'm plasma physicist investigating solar plasma in particular.
Okay.
So this is why we came to the involving the theoretician, because I wanted to understand as a physicist what is causing these waves.
Right.
I can explain very nicely flares and what is produced by them, different emission from the corona to the photosphere and sunquakes, but this was absolutely puzzling. So we needed specialists from different fields who can explain us and bring